Rational expressions. We started talking more in depth about rational functions on Friday. We said that a rational function was something in the form of f of x equals p of x over q of x, where p of x and q of x were both polynomials. Okay, and we talked about domain and range and some stuff like that. Now what we're going to do is, if we have two rational functions, how are we going to deal with simplifying those, multiplying those together, dividing those? Okay, if you recall, we have done multiplication and division of functions before, so we're just going to extend that to be multiplication and division of rational functions. But before we do that with the functions, we want to deal with rational expressions in general. The nice part is all the rules that we're going to deal with are the same exact rules we used when you're simplifying fractions, multiplying fractions, dividing fractions, like 2/3 times 1/4. It's the same exact rule, it's just now instead of strictly constants in your fraction, you're going to have polynomials. So here, which of these rational expressions is in simplest form? So you have to think back to fractions that are made up of nothing but constants. What does it mean for a fraction to be in simplest form? It means your numerator and your denominator do not have any common factors other than 1. Right? Like 2/4, for example, is not a fraction in simplest form because 2 and 4 each have a factor of 2. You would factor that out, and the simplest form of 2/4 is 1/2. It is the same exact rule here. So we have 4 rational expressions. I will tell you that one of those is in simplest form. Which one is it? The only one of these 4 that's in simplest form is the first one. You cannot factor the polynomial x plus 1, nor can you factor the polynomial x plus 3. So you can't factor either of those, so you'd have to see something there that cancels out, and nothing does. Okay? So that first one is in simplest form. This second one, this is x over x squared, which is 1 over x. Right? That's like having x over x times x. These ones cancel out, and you're left with 1 over x. The third one, we want to factor the numerator and factor the denominator as much as we possibly can. So for this one, we have to remember a formula for the difference of squares. That numerator factors as 2x plus 4 times 2x minus 4 all over. In the denominator, all we can do is GCF factoring. That's 3 times 2x plus 4. So when you're trying to rewrite a rational expression in simplest form, the first step is to factor the numerator and factor the denominator completely, which we had some practice reviewing how to factor polynomials last week. And as I said last week, factoring polynomials is going to be incredibly important throughout the rest of this chapter. Now, we're at this point, we can see that 2x plus 4 will cancel, so the simplest form here, 2x minus 4 over 3. And then the fourth one, we have a quadratic over a quadratic. Factor them as much as possible. Numerator factors as x plus 2 times x minus 1. Denominator factors as x plus 2 times x plus 4. X plus 2's cancel. We are left with x minus 1 over x plus 4. The other thing that we're going to have to worry about in this section is you may be asked to simplify and then state any excluded values. What does it mean by excluded values? When they ask for excluded values, they're asking what values of x are not allowed. So in this first example, x cannot be -3. And again, the reasoning is the denominator cannot be 0. In the second one, x cannot be 0. In the third one, x cannot be negative 2. And that third one is a good example of where you're obviously not looking at the simplified form. Because the simplified form of this one, there is no x in the denominator. To get your excluded values, you have to look at the original. What value of x makes this 0? X cannot be that value. And in that third one, that value is negative 2. And then the fourth one, x cannot be negative 2. X also cannot be negative 4. So in that one, there are 2 excluded values for x. So again, like we said on the previous page, to rewrite this in simplest form, you want to factor the numerator and factor the denominator separately as much as you possibly can, and then see if anything cancels out. So in the numerator there, I'm just going to do GCF factoring. 3x times, 3x plus 2, all over 12 times 3x plus 2. GCF factoring is always a good place to start. We just want to look. We have completely factored both the numerator and the denominator. Does anything cancel out? The 3x plus 2's cancel. Anything else?
Yeah. 3.
Correct. The numerator has a 3, that'll become a 1. Denominator has a 12, that'll become a 4. So this simplifies to be x over 4. Are there any restrictions on my variable? Perfect. The denominator cannot be 0, so x cannot be negative 2/3. And again, the way we get that number, you just take this linear factor here and say 3x plus 2 cannot be 0, and solve that like it's an equation. Subtract 2 from each side. 3x cannot be 2. Divide each side by 3. X cannot be negative 2/3. That's how we get our excluded values. We want to multiply these two rational expressions together, and you'll see again they're asking, what is the product, and then state any restrictions on the variable. The best way to begin a problem like this, where you're asked to find the product between two rational expressions, is to factor everything as best you can. You have 4 polynomials to deal with here. 1, 2, 3, 4. Factor all of them as best you can. So we have x minus 2 times x minus 1 all over x plus 2 times x plus 2, or x plus 6. X plus 6 times x minus 6 all over x plus 6 times x minus 1. So take each of the 4, and in this case, this one factored thusly. This one, using the difference of squares formula, factored thusly, and this one factored thusly. The reason that we want to factor everything as much as possible is that now we can see, remembering how fractions work, there's an x plus 6 over x plus 6, so that's gone. Then, if you recall, when you multiply two fractions, before multiplying you can cross-cancel. So you want to look here and here. If anything is the same, you can cancel it out. X minus 1s. Then you want to look here and here, see if anything cancels out. There, nothing does. So what we are left with is x minus 2 times x minus 6 all over x plus 2. And we can even just leave it this way. This is the simplest form. You don't have to FOIL the numerator. You could, but you don't have to. Now, what are the restrictions on the variable? From the simplest form, we can see that x cannot be negative 2. But we have to remember that the restrictions do not come from the simplest form. The restrictions come from the original problem. So x cannot be negative 2. X cannot be negative 6. X cannot be positive 1. So we have to remember this is just the simplest form of the expression, but we are dealing with this expression. So you have to look here, here, and here to get your restricted values for the variable. So we are multiplying and then dividing rational expressions. If we remember how to deal with fractions in general, we understand that multiplying and dividing rational expressions are not really in any way different. Because to divide two rational expressions, what do? Multiply by the reciprocal. So we have 6x minus 3x squared over 36 minus x squared times x squared minus 5x minus 6 over x cubed minus x squared minus 2x. So if it's a division problem, then you just rewrite it as multiplication. Then you go through the process we did on the previous page. We have 4 polynomials. 1, 2, 3, 4. And we want to factor each of those 4. So we take up here, we're going to say 3x times 2 minus x over 6 plus x times 6 minus x times x minus 6 times x plus 1 all over x times x minus 2 times x plus 1. The only one there that you may have to look at for a second, in this bottom right-hand one, you take out the GCF of x, which leaves you with a quadratic, which then factors as x minus 2 times x plus 1. So make sure you understand how all 4 of these factor. We just have to remember if any of the linear factors up here match up with any of the linear factors down here, they cancel out. We have x plus 1, x plus 1. We have x and x. The last thing we need to realize here is an algebra thing that we should be aware of, but we're going to review it. If I have a minus b over b minus a, that simplifies to be negative 1. For example, if I have 5 minus 3 over 3 minus 5, that is 2 over negative 2, which is negative 1. So if we look, we have x minus 6 here, 6 minus x there. We have 2 minus x, x minus 2. So these ones cancel, leaving behind a negative 1. These ones cancel, leaving behind a negative 1. So we have, let's write this all out, what we have left is 3 times negative 1 times negative 1 all over 6 plus x, and that's all that's left in the denominator actually. And if you want to look at it another way, if I have 2 minus x over x minus 2, that's negative 1 times x minus 2 over x minus 2. Because if I factor a negative out of here, this becomes negative 2, this becomes positive x, x minus 2. So that's how we get our negative 1. Then in our problem, we have two negative 1s. What's negative 1 times negative 1?
Positive 1.
Positive 1, so we get 3 over 6 plus x. And our excluded values are going to be what? This is the original problem. What are our excluded values? So our excluded values, x cannot be 6 or negative 6, 0, 2, or negative 1.
You're frozen. 6.
So we have negative 6, 6, 2, 0, negative 1.
Does it matter? Do you have to put them in order?
No, no. Just list, make sure you get them all. Right here.
Yeah.
So we have a circle and we have a hexagon. The area of a circle is given by pi r squared. The perimeter of a circle is given by 2 pi r. The area of a hexagon is given by what? If we say that S is the length of a side, the perimeter, and they tell us it's a regular hexagon, the perimeter is 6S. The area is 1/2 A times P, where A is apothem. Okay? True. Now, we want to solve this for R and this for S. Easy enough, right? P over 2 pi is R. P over 6 is S. Then what we want to do is find the ratios of area to perimeter. Because they don't give us many numbers in this problem, but they tell us that the perimeters are the same. So we know not what the perimeters are, but that they are the same. So for the circle, we get pi r squared over p. But we know that right here, r is p over 2 pi. So that's pi times p over 2 pi squared over p, which is pi times p squared over 4 pi squared all over p. In here, this cancels out with this, and we have the p's cancel, so this all becomes p over 4 pi. That's for the circle. In the hexagon, we want to be able to figure out what this is in terms of S. We know that we have a regular hexagon. We know this is the apothem. We have a right triangle there. Yeah, we know all that. Wink. This right here is a 60-degree angle. So what we have is a 30, 60, 90 right triangle. So we remember that this length right here is A over square root 3. We all remember that. Now, this is also half of a side length. It's 1/2 S. So A is root 3 over 2 S. So to get my area divided by perimeter for the hexagon, the area is 1/2 A times P all over the perimeter. Right? Right. The p's cancel, so we are left with root 3 over 4 s, we know that S is P over 6, so this is root 3 over 4 times P over 6. And again, it's important that we're rewriting it in terms of P because we don't know what P is, but we know that P is the same thing here and here. So this is root 3 over 24 P. This is 1 over 4 pi P. Which one of these numbers is bigger? Using your calculator, you find that this one is actually larger. They are asking which jewelry box uses less material for the bottom and for the lid if the perimeters are the same. So the regular hexagon uses less material if the perimeters are the same. Since this number is larger than this one, the circle is actually going to use more material than the regular hexagon.